I'd like to talk a little bit today about the forecast confidence whenever we have a storm potentially looming on the horizon, as is the case this weekend for the eastern part of the country. We'll see various solutions from one model or another. This model says that's likely to happen. That model says this is more likely to happen. You might not be aware that these models actually have a number of different versions that are run for each one, and that helps us to kind of gauge how confident we should be or how confident we shouldn't be in the actual output from each model. And the reason for doing this really has to do with the butterfly effect, which if you're not familiar with from chaos theory, you can Google that. But basically, imagine if you're a golfer and you stepped up to the tee and you kind of hooked or sliced the ball off to the side. At first, you might be kind of using some body English and saying, maybe it's not too bad, but the further down it goes, the further away from the fairway it gets. And it'd be the same thing if you're bowling. Sometimes you let the ball go not quite right, and you still might hit the mark on the lane, but you end up hitting the head pin dead center, or maybe you just missed the pocket. Now imagine if that bowling alley was 100 times longer than it actually is. Where would the ball end up with that same shot by the time that got all the way down to the pins? Well, it would certainly be off of the alley and probably not even in the same bowling house. In fact, it probably wouldn't even be in the same town by the time it got down there. So that shows us that small initial errors can be amplified into very large errors when you get further and further out. And when you're making a forecast that's 4, 5, 6 days out for a system that might have its origins over the Pacific Ocean, or maybe it's just coming onto the West Coast, small errors in the models initially are going to lead to very large errors by the time the storm gets to the East Coast. So we need to determine how much play there is, how much wiggle room we have with these forecast solutions. And that's done by changing the initial conditions slightly, rerunning the model, and then doing the same thing over and over again, and seeing how much just changing things a little bit at the start will end up in the final result. And this is done through what's known as ensemble forecasting. And what I have up on the screen here is the GEFS. This is the GFS ensemble suite. And this consists of 20 different versions of the GFS. So the one you see on television or on the web, that's usually the operational run. But it's run 20 other times. And each time the conditions that start off are slightly different. So what we're looking for is consistency or lack thereof of the individual ensemble members. If there's a lot of agreement and consistency between each of these 20 runs, even though you change things slightly each time, then we can be fairly confident that the model's probably going to be fairly accurate in its forecast. But if the individual members are all over the place and there's a wide variance, it gives us very little confidence in the actual operational solution to that particular model. So at this point, the GFS is the one that's been putting out bigger snow amounts for southern New England for this weekend storm. The European has lower amounts, and they've both fluctuated a little bit over the last day or two. But this is the latest ensemble run available for the GFS. Now, the first box here is the control run. This is with no alterations made, and that's sort of like the base that we're going to compare everything to. In the first ensemble member, we're not going to go through all 20. We're not going to take all day, but just to give you an idea, here's one iteration, the first ensemble member, where the conditions were changed slightly. You can see that the northern, and by the way, this forecast period is precipitation ending, the 6 hours worth of precipitation ending at 1 a.m. Sunday. So if this was going to actually happen, if this storm actually happens, you would expect significant precipitation to have fallen by this time. And we can see the northern extent of this precipitation cuts through southern New England, right near the Connecticut-Massachusetts border, actually, and then kind of down here into central Pennsylvania. That's one version. Here's another version. Again, the conditions changed slightly, models rerun again. Notice where the low center is on the first version. On the second version, after changing conditions just a little bit at the start, the low center, the storm center, is much further south, and there's actually no precipitation that I can see here in Connecticut or most of southern New England, except for the Cape, for the same time period. So you have zero output, zero precipitation output for that 6-hour period ending at 1 a.m. Sunday on that particular ensemble member. And we can go through all of them one by one. This is what you would do when you're putting a forecast together. Here you have the northern edge, again up here somewhere in northern Connecticut, southern Mass. This one has some pretty good precipitation for the same time period. This is a little hard to see, but it doesn't look like there's much output on that one. This ensemble member, on member number 6, again, no precipitation through most of southern New England and southeastern New York for the same 6 hours ending at 1 a.m. Sunday, the first part of Saturday night. So, and here's another one that has little or no precipitation over the area. This one too. So we could go through all of these, and you know, a lot of them don't have any precipitation at all put out over the area. The last one down here is actually an average of all of these ensemble members, and what this shows is for that 6-hour period that ends at 1 a.m. Sunday, fairly light precipitation over most of Connecticut and southern New England, and the low center right about here. So, you know, I don't have a lot of confidence in this model's operational output because these ensemble members have a wide range. They're all over the place, and a lot of them don't even give us precipitation or very little of it. So it's hard to have much confidence in the GFS model at this point, which is putting out the most snow for southern New England. I'm still leaning more toward the European model. You can go through the same exercise as that's run in an ensemble, and the European has 50 different ensemble members to look at. So, you know, if you hear me mention a high or low level of forecast confidence, this is in part what goes into that.